Hello everyone and welcome to the new video. So today we are going to see what is ZigBee. So ZigBee is actually one of the important part in wireless communication or in a wireless network. So it plays a very important role in comparison with your Bluetooth and other technologies, but it has its own cons and pros. So we'll see why to use ZigBee and what are the different technical aspects of this ZigBee technology. So let's just begin. So whenever we see a wireless technology is being developed rapidly, we could say there is a rapid development in wireless technology, and just because of advancements in your micro electromechanical systems, which are better known as your MEMS, like your accelerometer and all those things. So there is actually a drastic development in the MEMS, micro electromechanical systems. Okay, so that brings actually a integration of your sensing, signal processing, and we could say RF capability on very small devices. Okay, so all kind of portable applications tend to be able to communicate without the use of any wires. So aim of your wireless communication nowadays is to gather information or to perform a certain task in the environment. So a typical sensor node, we could say, for any technology, if we'll say that we are using some sensor node, in that case it includes three C's. Three C's. Okay. So what are these three different C's? So the first C is collection, and the second one is actually your computation, and the third one is actually communication unit. So whenever you need to understand what is a sensor node, in that case you need to understand these three C's, that there is a collection, computation, and communication units. So based on a request of sync, or we could say based on the request of sync, gathered information will be actually transmitted wirelessly. So the collection unit has actually we could say there is a series of sensors. So computation unit actually, if we say, then computation unit will contain a microprocessor or controller and a memory. So finally your communication unit actually contains transceiver to transmit and receive your data, and various transceiver, like there is actually different families are there. TR1000, which is actually known as RFM TR1000 family. Hardware accelerators are there. Then there is a chipcon CC1000 or CC2420 family. Even there is a family of EM2420 RF transceiver. There is also, again, we could say TDA525X family is there. Then there is actually one of the family which is related to 802.15.4 amber. Okay, so that is actually EM 2420 RF transceiver. Then even RD triple S 9M kind of a version is also there. So these are actually different families which are actually associated with these various transceivers. Okay, so whenever we came to some kind of trouble, like whether to choose a ZigBee or to a Bluetooth. So today's topic is actually ZigBee. So if I need to select a reason to use a ZigBee, so I would just note it down, like if I need to use ZigBee, then first important point for ZigBee would be it's reliable and self-healing. Okay, then even it supports large number of nodes, so that is actually advantage for me. Supports large number of nodes. So how come this could be easy for us? So wherever there is extensive application where you need more number of nodes to be deployed in a network and you need to control them, so at that point your ZigBee becomes more important to you. Okay, and actually ease of deployment is there in this ZigBee, or even you could say easy to deploy. Okay, then there is actually, we could say, due to the functional operation is like that, so your battery life is quite longer battery life. Even I could say it's secure. There is cost of this ZigBee devices is low. Then even it can be used globally because it's a global standard, and it is actually designed by your ZigBee alliances. So we could actually easily use it anywhere globally. So if we need to say, so obviously this is a wireless technology, so that is one of the best advantage. And even to use it, uh, like we could say, we can easily upgrade our firmware even locally. Okay, so if we need to update our firmware, then it's no need that at each node I need to go there. So you can actually remotely upgrade your firmware. Even the chipset available is from multiple sources. Open standard protocol is used with no negotiable licensing fees. Even vibrant industry support with the, we could say, 30 or more vendors supplying this product and services. So because of these kind of reasons, or even more are there, like this, your low power and all those things are actually your key factors. Because if it is low power, it is actually, we consider ability to operate on batteries, so it could be measured in your years. So even for these kind of systems like this ZigBee, the maintenance is actually quite low. Okay, so that could be also considered as the advantage for us. So how could be a low maintenance? So low maintenance in the sense of meshing and self-organizing. And even we have in this ZigBee, we have actually standard based security. So there is actually one protocol which is actually called as AES 128 is there. So even even many more are there, like ability to read your different gas meters and all those kind of things. So you could actually use ZigBee as, or we could say ZigBee is actually one of the most widely utilized wireless sensor network standard, with actually a low power, low data rate, a low cost, short time delay characteristic, and simple to develop and deploy. Okay, and it also provides you a robust security with high data reliability. So uh, name of this ZigBee came from actually like zigzagging patterns of your honeybees between flower, and represents actually communication between your nodes and mesh networks. So that's why this name is being suggested to be a ZigBee. Okay, so that's why this Zig and B is being combined and it has been named as ZigBee. Okay, so this is just a general introduction to your ZigBee. So now we need to see what is actually in general. If you will search, you will find out that ZigBee and IEEE 802.15.4 is considered as same. But no, we need to understand what is actually a difference and what is actually a common thing. Okay, so we'll just get into what is a ZigBee and IEEE standard. Okay, so ZigBee is actually developed by your ZigBee Alliance. Okay, so which has actually hundreds of member companies like your Amber, Freescale, Chipcon, then Invencis, Mitsubishi, Compax, even ME Semiconductor, NQ Semiconductors. So these actually different companies are there. So even semiconductor and software developers are associated with it, to like original equipment manufacturers are there. So ZigBee and 802.15.4 are not same. Okay, so understand this word, ZigBee and 802.15.4 are not same. Okay, so you need to understand this difference. ZigBee is a standard based network protocol which is supported solely by your ZigBee alliance that uses a transport services of your IEEE 802.15.4 network specification. Alright, so ZigBee alliance is actually responsible for your ZigBee standard, and IEEE is responsible for 802.15.4. So it is like TCP/IP using IEEE 802.11b network specification. Okay, so that will be a simplest as that. So ZigBee Alliance or your software define the network security and even application layer. Okay, so whenever it comes out like what ZigBee does, so ZigBee Alliance defines your network, your security, and even your application layer. So these are the three key factors. Okay, so that you need to remember. So IEEE 802.15.4, which is actually a hardware that defines physical and media access layers. Okay, so this is a ZigBee and this is your 15.4. What it defines is actually we could say this is a software, so it's better to write a software, and here for this is a hardware. All right, so this will be actually defines your physical, right, and we could say media access control layer. Control layer, right. So for your we could say this is for actually your LRWP, because it's well known 802.15.4 is considered as low rate WPAN devices. Okay, so the function of this thing is for physical and media access control layer. Okay, so power needed for ZigBee is very small. Okay, so in most of the cases it uses like approximately we could say 1 milliwatt. Okay, or less, but still it provides a range up to your 150 meters. Okay, so 150 meter, but it's not an indoor, in a outdoor, which is achieved by your technique called as DSSS. Okay, so this 150-meter outdoor can be achieved using your spreading technique. What is this technique? DSSS. So it is one of the spreading technique which is known as direct sequence spread spectrum. All right, so also your DSSS consumes less power as to that of your well-known technique as FHSS. Okay, so which is actually frequency of spread spectrum. Okay, so these DSSS will consume less power, FHSS will consume more power. Okay, so it works in actually your almost like 868 megahertz in Europe. Okay, 915 megahertz in your North America and Australia, and 2.4 gigahertz available worldwide. Okay, so that is actually your ISM band up to like 20, 40 to 50 kbps data rate respectively. Okay, so if you want, I'll just write it down here. So this is just additional information. So the band, if we need to consider, so first I have said 868 megahertz. Second one is your 915 megahertz. Alright, and your third one is your 2.4 gigahertz. So this is used for your used in your Europe. Okay, this is used in North America actually. I could say North America and Australia, and this is actually your worldwide. Okay, so these three are there. So you could actually utilize worldwide everywhere with the data rate of we could say 20, 40 and 250. Okay, so these are actually your kbps. So 20 kbps for this 868, 40 for 915 and 250 for 2.4 gigahertz. Okay, so because these wave bands are actually different from bands of current common wireless network or wireless fidelity or your Bluetooth or wireless USB, etc. So the mutual interference between them will not occur. So therefore this guarantees our system will not interfere other wireless network and will not be affected as well. Okay, so that is actually we could say is a good thing. So IEEE 802.15.4 standard employs actually your 64-bit and 16-bit short addresses to support theoretically. So more than 65,000 nodes per network. Alright, so you could understand how complex could be this value. So ZigBee network can have actually up to we could say 655 no 653,356 devices. Okay, so this is a number. Okay, I'll just write it down again. 653,356. These many number of devices. Okay, ZigBee network can have. The distance between your ZigBee devices can be up to 50 meter. So now understand this is a network with a distance of 50 meter. So each node can actually relay data to other node, and this leads capability of making very big network which is covering a significant distances. So actually from the values even you could understand that if it is this kind of single network of 6,53,356 node in one network with a spacing of 50 meters, so you can understand how much bigger this network could be. So was it possible with a Bluetooth? So obviously yes, but we could say not sure. But with ZigBee this is possible case. So that's why ZigBee is different than your Bluetooth. Okay, so let's talk about some of the standards in your ZigBee. So I hope until now you have got much of the information about your ZigBee and your IEEE 802.15.4. Okay, they are not same. ZigBee is your software, IEEE 802.15.4 is your hardware. So the entire architecture when we will see or protocol stack and that kind of things whenever it will came into picture in detail, I'll let you know what are these differences. Okay, so till now ZigBee is cleared. Okay, so we'll just talk about some of the ZigBee standards. So we could say ZigBee devices are actually combination of application like your light sensor, light control. Then there is a ZigBee logic is also there, which contains actually your coordinator, router, devices, which is actually well known as your end devices, and your ZigBee physical devices type. So like full functional device and reduced functional device. So instead of just telling you this thing, I'll just give you a brief write up. ZigBee, so it does have actually, I'll just divide it among three. Okay, so consider these three. So instead of just ZigBee, I'll write ZigBee devices. So they do contain what are three different types. So one is your application. Okay, so what are the applications? So such as your light sensor, lighting control. Okay, and what is next? Next is your ZigBee logical. Okay, so I'll just write logical. So what it contains is coordinator, your router is there, and your end device is there. And in a third segment of your ZigBee device, they do have physical device type, in which there is actually FFD and RFD, full functional device, reduced functional device. Alright, so whenever it comes out to be a ZigBee, we need to understand there are these three different segments. Alright, so just start with we'll just begin with ZigBee physical device type. Okay, so we'll just start with this thing. So based on your data processing capability, so depending on your capability of data processing, uh, there are actually two types of physical devices are provided in your IEEE standard of 802.15.4. So they do have as a full functional device and reduced functional device. Okay, so full functional devices can perform actually all available operations within a standard, including your routing mechanism, coordination task, sensing task. Okay, so I'll just write it down so that whenever next time you will refer this video, it would be easy to understand for you. Okay, so what we could write, uh, so for, I think it's visible, yes, FFD. Okay, so FFD plays role of your coordinator, router, and your end device. Okay, so it can be actually either FFD or RFD depending upon your intended application, but this remains same for your whether it's FFD or RFD. All right, so a typical FFD in ZigBee network will be powered from your AC fed main supply. Okay, as it must always be active and listening to a network. So reduced functional device on the other hand implements a limited version of your 802.15.4 protocol. Alright, so RFD do not route packet and must be associated with your FFD. Okay, so these are end devices such as like your sensor, actuator, which only doing limited tasks like your recording temperature, or recording any other data, monitoring lightning condition, or controlling external devices. So the current ZigBee standard requires actually FFDs to be always on, which in practical means that FFD must be constantly powered. So battery powered FFD have a lifetime on the order of few days. So it's obvious that whenever we'll see that your ZigBee will be operating on battery powered, so it's not sure that how many days it will survive. So if you tentatively say by 4 days it will saturate, so you need to replace it by 3 days. So this is a thing. So we'll just think about now in a reverse order we'll go. So the second is your logical. Okay, so ZigBee logical devices type. So there are actually three types. So there is a coordinator, there is a router, and there is a end device. So what is this coordinator? So coordinator is actually forms a root of network tree and might breach to a other network. Okay, so there is exactly one coordinator in each network. It is responsible for initiating your network, selecting a network parameters such as your radio frequency channel, like unique network identifier, and setting other operational parameter. So it can also store information about your network and security keys. So just like in a Bluetooth, in a small network there was a case like there was a master and slave. So here it is actually a different words. So here it is a coordinator and slightly different functionality. Okay, so whenever it's a case of your router, in that case router acts as your intermediate node. Okay, so relaying your data from other devices. So router can connect to already existing network also able to accept connections from other devices, and be some kind of retransmitters to a network. Okay, so network may be extended through the use of ZigBee routers. All right. So one more thing is there, which is actually a end device. So end device can be a low power and battery operated devices. All right. So they can actually collect various information from sensors or switches, and they have sufficient functionality to talk to their parents. Okay. So either the coordinator or your router. So coordinator and router are parents of this end devices. All right, and they cannot relay data from other devices. So this reduced functionality allows the potential to reduce the cost. Okay, they support better low power models. So these devices do not have to stay awake the whole time, while the device belonging to other two categories have to. Okay, so while these two work, this will be idle. All right, so each end device can have up to 240 end nodes. Okay, so you can understand how much complex structure could be there. So I'll repeat the statement I have made is each end device can have up to 240 end node. Okay, so end device can have 240 different end nodes, which are actually separate, which do have actually a separate application sharing a same radio. Okay, so if I need to draw the kind of a network, in that case I'll say, uh, I'll just roughly draw a thing for your ZigBee network. Okay, so what I'm drawing is your ZigBee network. All right, so they will actually comprise of your these three elements, whatever these logic devices are there: coordinator, router, and end device. Okay, so whatever C is written, it's actually your coordinator, R will be your router, and end device will be, we could write E. In some of the books, they could write, or some of the references you could see, they generally prefer it to be a F. I don't know what is F. I know what is end device, so I am representing it as E. Okay, so I'll just draw a rough diagram. Okay, so this might be connected to this is connected to this is connected to this. So this is your R, even this is R, this is R. So here there could be a E, here again there could be a E, one more E could be there. Okay, so if I need to extend, similarly you can draw anything, but you need to just understand what are these different nodes we are connecting and what are the functionality of it. Okay, so C is coordinator, R is router, and E is end device. Okay, so this comprises of your entire ZigBee network. All right, so let's move on with the access modes in a ZigBee. All right, so these are these different access modes. So two ways of multi-access in ZigBee protocol are like, there's two types, which is actually called as a beacon and non-beacon. Okay, so if there is a space, I'll just write two modes of multi-access in obviously ZigBee. So one is beacon, another one is non-beacon. All right, so in non-beacon actually, non-beacon enabled network, we could say every node in the network can send the data when the channel is actually free. But in a beacon enabled network, node can only transmit predetermined, if it is allotted with some predetermined time slot, then it can already always transmit in that particular slot itself. Okay, so that is a slight difference, that in beacon enabled network only predetermined time slot, and in non beacon you could actually say every node in a network can send data whenever you feel like there is a channel free. Okay, so PAN coordinator actually allocates your guaranteed time slot, which is actually very well known as your GTS, for each device. So therefore your devices will transmit their data during their own slot. All devices should be synchronized for this process. This will be actually achieved by sending your beacon signals. Okay, so the coordinator is responsible to transmit your beacon signals to synchronize the device attached to it, and the network in which the coordinator doesn't transmit your beacon signal is known as your non-beacon network. So it cannot have a GTS and a contention free periods because the devices are not synchronized. So battery life is better than your beacon enabled network because the devices are actually we could say wake up less often. Okay, so this is entirely we could say different than your Bluetooth. So in a Bluetooth it was actually a simpler one, but ZigBee is actually comparable, quite complex, and you need to understand what are the differences. Okay, so in the ZigBee standard we have seen different elements associated with it. What are the different access modes are there, what are different physical devices are there, logical devices are there. So these are different things. So one of the important thing we need to get into is your ZigBee protocol stack. So we'll directly move on to ZigBee protocol stack. So before explaining it to you like virtually, I would see that I could draw it quite fast. So I'll just draw it roughly. So there are three layers from your 802.15.4. They have been phased. So we have already talked about it, that 802.15.4 gives us or supports us with physical layer. So it's never actually you need to mug up all the things. If you know it actually logically, then you could actually put into a picture. Okay, so whatever we have talked, it's simply that way only, that we have said physical MAC and network will be supported, or only two layers will be supported with your 802.15.4. I could not say network layer, I'm sorry about that. There are only these two. Okay, so MAC and your physical layer, that will be supported by IEEE 802.15.4. and beyond this, please consider from network layer till the entire stack, whatever is there, it comes under or it is supported by your ZigBee alliance. Alright, so what is that? So first one is your network, then application layer. So you would say there is actually just a four layers, and why you are drawing application layer quite bigger. So I'll just draw inner things later on. So these are actually your security services. Alright, so now application layer. So what application layer will have more into it? So obviously it will have kind of we could say here I could have applications support sublayer. Alright, there'll be one more thing, there has to have a application framework. Alright, then there has to have ZigBee device object. Okay, so yes, one more important parameter I have just forgotten, APO1 till APO 240. Okay, I'll just explain these things one by one. So this is your protocol stack. I haven't drawn it quite fabulous. It's actually just a dull diagram, so just understand it in a 3D version. Okay, all right. So protocol architecture is actually you could see it's totally based on your OSI. Okay, OSI, open system interconnection. So ZigBee builds on IEEE standard 802.15.4, which defines the physical and media access control layers. Okay, so ZigBee Alliance actually defines your network control layer, okay, and your we could say application layer. So two layers are supported by your 802.15.4 and two by your ZigBee Alliance. All right. So we'll discuss one by one. So let's begin with the physical one. Okay. So the physical layer of your 80, which is actually supported by your 802.15.4 standard, is the closest layer to your hardware. Okay, which controls and communicate with radio transceiver directly. It handles all tasks involving to access the ZigBee hardware, including your initialization of your hardware, then channel selection, then link quality estimation, energy detection measurement, and even like clear channel assessment to assist channel selection. Uh, so this supports actually three frequency bands. Okay, so there is actually we have already discussed that thing previously. So what was those? So they were actually, I'll just extend it out here itself. So there was 868 megahertz, there was 915 megahertz, there was 2.4 gigahertz. Okay, so in megahertz, and this is 2450 if I'm writing, so then it is megahertz, or you could simply write 2.4 gigahertz. All right, but to be specific, I am writing 2450 megahertz. Okay, so in this actually we could say in 2.4 gigahertz we actually get channels, more number of channels. So with 2.4 gigahertz we get simply like 16 channels. With 915 we get 10. In 618 we get actually one channel only. So data rate, obviously we have already seen that there was actually 20, 40 and your 250 kbps was your data rate. And applicability, even you have seen that this was for your Europe, then this was for US, and this was for your worldwide. All right, so that is about your physical layer. MAC layer. Now MAC layer provides interface between your physical layer and a network layer. All right, so this provides actually two services. So what two services? So MAC data services and MAC management service interfacing to MAC sublayer, we could say sublayer management entity, or MLME. Okay, so the MAC data service enables the transmission and reception of your MAC protocol data units across your physical data service. So MAC layer is actually responsible for generating your beacons and synchronizing devices to the beacon signal in a beacon enabled services. Okay, so it's also performing association and disassociation function. It defines actually four frame structure like beacon frame, data frame, acknowledgement frame, and MAC command frame. Okay, so basically there are actually two type of topologies, like star and peer-to-peer. So peer-to-peer topology can take actually different shapes depending upon and it actually depends on your restrictions. So peer-to-peer is known as your mesh if there is no restriction. All right, so if there is a restriction, it's a peer-to-peer. If there is no restriction, it's a mesh. And another form is actually your tree topology. So interoperability in one of the advantages of, or interoperability we could say is a advantage of your ZigBee protocol stack. Okay, so ZigBee has actually a wide range of application. So different manufacturers provide a ZigBee devices. So ZigBee devices can actually interact with each other regardless of your manufacturer. So even if the message is encrypted one. So that is the beauty of your ZigBee. So next one is your network layer. So what is a network layer? So network layer interfaces between your application layer Okay, so interface, what is a interface? So it's an interface between your upper layer, application layer, and your Mac layer. Okay, so the each layer does have a functionality of, obviously if they are standing between two layers, so they will have a responsibility to transfer data over these two layers. Okay, so network layer actually interfaces between your application layer and your Mac layer. So this layer is responsible for your network formation and routing. So routing is a process of actually selection of path to relay the message to destination node. This forms a network involving joining and leaving the node. So maintaining like routing tables or coordinator router, actual routing, and your address allocation. Okay, so ZigBee coordinator or router will perform a route discovery. So this layer provides we could say network wide security and allows actually low power device to maximize their battery life. From the basic topologies, we could say there are three network topologies are considered. So as we have previously discussed, there is a star. We are gonna see the diagrams of it, but still I'm just naming it here. There is a star, there is a mesh, and there is peer to peer, right? So, or the better word, or if you need to remember an exact name for them, so there is a star, mesh, and we say cluster tree. Okay, so it is also known as star, mesh, and cluster tree, or whatever you say that to be a peer to peer, but it's very well known as your cluster tree. Okay, so last layer, your application layer. So it's a one of the important thing. So application layer is actually we could say highest protocol layer. Okay, and it hosts actually your application objects. So ZigBee specification separates to APL layer. Okay, into actually your application layer into three different sub layers. So the application support sub layer, the ZigBee device object. Okay, so the first one, second one, and third one. Okay, so just for namesake, these are different three we could say uh, three different parts we could say. Okay, so the application objects or APOs, what are these APOs? I have written here APOs. APO. So what are these APOs? So these APOs are called as, these are application objects. Okay, so function of these thing is to control so these APOs actually control and we could say they manage a protocol layer in a ZigBee device. It is actually a piece of software which controls the hardware. So each application object is assigned with a unique endpoint number. Then other APOs can use extension to a network device address to interact with it. Okay, so there can be up to 240 application objects in a single ZigBee device. Alright, so you must understand that there can be a 240 application object in just a single ZigBee device. Okay, a ZigBee application must conform to an existing application profile, which is actually accepted ZigBee Alliance. An application profile actually defines a message formats and protocols for interaction between your application object. So application profile framework allows different vendors to independently build and sell these kind of different ZigBee devices, and they can interoperate with each other in given application profile. Okay, so that is your function of APOs. So if we talk about ZigBee device object, what is this ZigBee device object? Then the key definition of your ZigBee is the ZigBee device object, which addresses three main operations like service discovery, security, and binding. Okay, so we can just note it down. So here it is, main functions are service discovery. Okay, what was second? Security and binding. Right, so these are the theme functions. So the role of discovery is to find the nodes, ask about MAC address of your coordinator or router by using unicast message. The discovery is also facilitating the procedure for locating some services through their profile identifier. So profile plays an important role. The security services in your ZigBee device object have the role to authenticate and derive necessary key for the data encryption. Okay, so the app network layer is actually implemented uh, in the coordinator, and its role is to select a existing PAN to interconnect. It also supports the creation of new PANs, and even the role of binding manager is to bind node to resources and applications, also binding devices to kind of channels. Okay, so the one last is your third one, application support layer or application support sublayer. The application support sublayer provides actually your interface between uh, we could say NWK and your APL. All right, so network layer and application layer. Okay, so by providing your APS data and management entities, so these kind of functionalities are there. So the upper layer issue primitives to APS sublayer is to use its services. So we could say uh, authentication entity or permission configuration or request key. Those are the all functions of this sublayer. All right. So I think I have done, yes, this one segment is remaining, security services. So security service provider. So I have just written completed. So security service provider. Okay, SSP. So this SSP, what is the function of it? So ZigBee provides actually security mechanism for your network layer, okay, and application support layer. Okay, so in general, actually it's responsible for securing their frame. Even the security services include methods for like key establishment, then key transport, even frame protection, then your device management. So these are actually functionalities associated with your security service provider. Okay, so actually this has to get extended to this thing. Okay, that is a slight change in your diagram. This should not end up here, this should go here. All right, so let's see what are the different topologies we have already seen. So even protocol stack we have seen in detail. So let's see, if you can find out whether these topologies are what. Okay, so I'll just tell you, this red one, wherever is this red one, these red ones are your PAN coordinator. All right, so these are PAN coordinator. These green ones everywhere are your router, and this blue one are your end devices. Okay, so from that you could easily understand what are these different topologies. So make a guess. So this is the most simplest of all these is this one. So obviously this is a star. Okay, so you can easily think of it. There is another thing slightly more, we could say this is simplest. This is actually, we could say this is simple. So obviously this resembles to your mesh, and obviously the last one remaining is cluster tree. So this is a cluster tree. Okay, so this is cluster tree, this is mesh, and this is your star topology. All right, so we have already seen these different topologies associated with your ZigBee. So in general, if I need to talk in short about this star, cluster, or mesh, I would say star topology consists of your we could say one coordinator and any number of end devices. In actually, we could say in star topology, kind of master slave network model is adopted. Okay, so here it is actually your one PAN coordinator is there, multiple number of end devices, multiple number of router. Okay, so this actually deploy kind of, we could say, uses master slave configuration. Okay, so they adopt that kind of thing. So in this, we could say, in this model, the master is actually your ZigBee coordinator, which is actually your FFD, full functional device, and slave will be either your FFD or RFD, okay, reduced functional device. So ZigBee end devices uh, are actually physically and electrically separated from each other, end devices, and they actually pass information through your coordinator. Okay, so devices can only communicate with the coordinator. Okay, so the main part in this network is actually the coordinator. All right, so devices can actually only communicate through your coordinator, and this does not provide multi-hop networking and mesh networking. All right, so it's simply like you need to follow master and slave configuration. So if it is case of mesh topology, in that mesh we could say each node can actually communicate with any other node because connection is that way. So within, but actually we could obviously say that one node can or each node can communicate with any other, but within a range. And mesh topology is actually complex to actually even maintaining or beaconing, and even those things actually not allowed in these kind of networks, but it is actually most robust and actually we could say and tolerance to fault. Okay, so if we look into now in a cluster tree, then the cluster tree topology is actually quite similar to that of your star topology. Only the difference is that other nodes can communicate with each other. So that is more, we could say, RFD or FFDs can be connected to your non-coordinator FFD. So the advantage of this topology, we could say, it is actually possible for a geographical expansion of your network. So out of these three, this is actually a basic topology. This is actually quite a complex one, but even complex in the case of maintenance and beaconing, even that is not allowed. So then the best option is your cluster tree, but depending upon variants available or depending upon your requirement, these can be employed. Okay, so next we could see some of the applications. So in general, your if I need to note down some of the points, then if I would talk about throughput of your ZigBee, so throughput for your ZigBee is quite low. Okay, and data transfer rate, if I will talk about, so data transfer rate is actually like 250 kbps. Okay, so ZigBee system is actually useful for application where you don't want a higher data rate. So with a minimum data rate, if you could work out, then in that case this is a best option. Okay, so some of the applications are like home automation, or like home automation with a control, automatic your meter reading, or for your housing or commercial utility system, like building automation you can for building automation you can use, even like for your we could say personal healthcare is actually one of the application for this thing, even like in a ban, which is actually a body area networks, even in like fitness monitoring, home or gym or on the move, these kind of bands are there, or we could say fitness monitoring segments are there, so you can use there. So even there is one of the better application is ZigBee Smart Energy. Even like they can be deployed in a hospital or institutional patient monitoring, and even like for it is actually a replacement for your cable. And even you can deploy this thing in automotives or for in vehicle control, like a vehicular and entertainment status monitoring, and even in telecom services. So it's actually a huge variety of application are available in your ZigBee. Okay. So just before ending, I would conclude that since there is actually, we could say, no global standard so far in wireless sensor network, or even it is there, but that is not actually that kind of modified or immersed. So ZigBee plays actually a vital role in most of the wireless application. In most industries, it is observed that there is an increasing demand of your ZigBee based wireless application. So in general, we have seen some of the descriptive standard things about the ZigBee. What are the different protocol stack architecture? What are the different topologies, and what are the different applications? So I hope through this video you have gained some important things about your ZigBee, and I hope to see you in a next video. Hope you got some relevant information and you have achieved something through this video. So thank you.